Well, greetings, students. It's good to be with you. I'm going to be doing the drill tap bore project again, Lab 1, but this time we're going to do it in Esprit-CAM. So you'll want to open up Esprit-CAM now on your computer, and we want to go to your files. So if you go to your desktop and you look for, I'm going to have to pick up where mine is, but you're going to go to CNC2 2025-2026 students, double click on that, and then go to CNC2 2025-2026 students Esprit-CAM. Double click on that, go to 2D DXF part files, and then DXF drawings, and then pick up milling drawings, and then finally Lab 1 drill tap bore plate revised drawing. Click on that, open that up. And now we are ready to get started here. As you'll see over here in my layers, there's quite a few layers here on this. So in order to make sure that we get everything on the first layer default, we're going to double click on this and make sure that we make it active. And then all the rest we're just going to leave alone. Then we're going to grab everything, okay? Just draw a box around it. Make sure your highlighter is on down here to the lower right so that when you release it, it grabs everything. And then we're going to go ahead and copy this. So we'll go up here and we'll say right click and say copy. And we're going to say attribute. And we're going to go down here to layer. And you will see that there's the default layer is already active there because I double clicked on this and made it active over here in layers. And what I want to do here is I want to move everything over. So I want to make sure I say move here and not copy. All right, so I'm going to say move and say OK. And now when I uncheck default, everything disappears. All right, the next one, I'm going to rename this. So I'm going to click on it and rename it. Right click and rename and call this dimensions. And say OK. And then the third one I'm going to use as a machine layer. And so I'm going to right click on this, rename, and this is going to be machine. MACH abbreviated is fine. And then I can grab all of these, hold your control key down, grab all the other layers, and right click and say delete. And you'll get delete this layer, will remove 0 elements, are you sure? Yes. So now we are down to our 3 layers that we want. The next thing you want to do is make dimensions active, and now I want to go in here and I want to collect all of the dimensions. You can use a box and go around here. Mastercam wants you to pick them separately, but one thing good about Esprit, it lets you grab a lot of things at one time, but you have to hold your control key down when you do it. Mastercam, you don't have to hold the control key down, just so you know the differences. Grab all of these, make sure you get all of your arrows and all of your information. Also notations down here. And then you can double check to make sure everything's good there. And then you can grab the template. So I'll grab that. Grab that. Grab this up here. There's some notation marks up there that I need to grab. All of this. And then I can start working on the 3D and grab what I need to here. Again, draw boxes around it and get everything at one time as much as possible. And then just double check and make sure everything looks good. And then you're going to right click and say copy, and this time you're going to make sure that this layer says dimensions, and you're going to say move again, and you're going to say OK. So at this point, if I uncheck dimensions, everything should disappear with the exception of the actual geometry. So I'm going to go ahead and turn that back on. And now I'm going to move my origin point. Just like with Esprit CAM, you have to move your origin point in just like in Mastercam, you have to also capture the lower left-hand corner of your Cartesian coordinate, or put it right there. So I'm going to go up here and say Edit, Move Origin Point, and then I'm going to zoom in and bring it hover over that corner there. Click on it, and now it is on the lower left-hand corner. So I'm going to go up to default here, and I'm going to change default now and rename it to geometry. And say OK. So now we have geometry, dimensions, and machining. Since we have the dimensions captured right now, and we have our Cartesian coordinate where we want to, we don't necessarily need to have the dimensions at this point, but we do want to be in machine mode so that we can do all of our chaining work and get all that ready and get our tools made. So it's very important that you get all of this stuff done ahead of time so that you're not trying to come up the back end. So at this point, we're going to go ahead and we're going to do a couple of things with this. You'll want to get rid of the crosshairs here on all of these. The reason being, it's so easy to pick the end of this line here. You can easily hover over this and pick a line down here, which is not correct. So the best thing to do here is just delete all of these lines and leave only the intersections. This is your best bet to make sure that you don't end up grabbing the wrong point. Do this for all of these. And then we should be good to go with our chains. It's also good for making sure that your chains is put at the right place as well. This is what I call drawing preparation. When you import a drawing in DXF format or data exchange, some things are going to be funky. There might be a split in a line or something, and you need to fix all that before you get started. So it's important, that all those kinds of things are taken care of right up front before you get started with creating any chains. All right, so as far as tools are concerned, we need to first tell Esprit that we're doing milling, a milling operation. So go up here and go to Machining, Solid Mill Traditional, and click on Solid Mill Traditional. And now it knows that it's going to be a solid mill operation. And then we can go up again to Machining and go to Common Machining, and then Machine Setup, and then make sure we put in our program number. So I'm going to say 100 here, and I'm going to, 125. I think I gave the Mastercam 100. So there's my program number. As far as the assembly is concerned, there's nothing to do here. So you just say OK, and you're all set now. Now we want to take a look at our at tools. Now, before we made this into a machining solid mill traditional operation, many times there is not the tool file down here or tool icon. Some of you have asked me that in the past, and that's because Esprit CAM didn't know what you were going to do with this wireframe drawing. It doesn't know if you're going to mill it or drill it or what you're going to do until you tell it that you want to do a milling operation on this. Once that happens, it'll put the category of tools down here for you. Now, all of you should have tools in your files. So it looks like this, where you have Documents, DP Technologies, Esprit Data, and then Tools. And you have drilling tools, milling tools, and turning tools. So Mastercam has all of these tools already listed. You have to pick and paste them and drag them. In this case, you just need to go to the tools that you're going to be using. So in the first case, I'm going to be doing a face milling operation on this first, because we're going to do this project in a different way than we did in CNC 1. We're going to put this in a vise. It's going to be down on top of parallels, 1/4 of an inch into a vise. And then we have to allow for extra material for that to happen. We have to add 1/4 of an inch on the material at least just to sit in the vise, and another 32nd on the top to do the face milling operation. So this is going to be a real-to-life type of an operation here now, where we're going to do periphery milling, facing, drilling, tapping, boring, counter boring, and thread milling. All right, just the same way we did with the Master-Cam. So I'm going to start out with milling tools, and I'm going to say open, and I'm going to look for a 2-inch face mill. And right there it is, and I'm going to say OK, and the 2-inch face mill comes in. Right off the bat, it says tool number 6, and I don't want that, so double click on this and change this to tool 1. Your initial clearance is 100 thousandths. You want to go clockwise, cooling on, inch mode. Under the positions, you want to go home, home, and home. You want to make sure that you have this set up correctly so that we have the Z plus sitting this way. You want to make sure that your extension diameter is 2 inches, overall length 1.5, and 1 inch 250 sticking out of the holder. This is going to be a cylindrical type cutting tool. The shank diameter is 1.875, and the tool length, again, it remembers at 1.250, and the cutting length here is 375. Then we go to the cutter itself, and again the tool diameter is repeated, so it remembers that. The bottom clearance down here now is added to be 0.1875 at a 30-degree angle. The cutting length then will be, again, 375. It remembers this, and the number of inserts 4. And the shank diameter again is 1.875, and the tool length, again, it remembers at 1.250. Then the last one, it's rectangular. We have a rectangular insert. So there's other possibilities here, but in this case, we're going to be using a rectangular insert. The corner radius on this right here at the edge is going to be 0.0315, and the insert width is going to be 0.375 and 0.5 that way. So now that's complete, and we're going to say OK, and now we're ready for the number 3 center drill. So we'll go up here, say open, and we're going to search for under milling tools. Actually, we're going to search under drilling tools, so you need to come back one and look for number 3 center drill and hit open. So the 3 center drill is tool number 2, which that's good. We just want to go in here and double check and make sure everything is okay. It's tool number 2. Home, home, and home is good. This is good here. Our our holder is fine at 1.5. 2 inches inserted into the holder, 1 inch sticking out. It's a cylindrical tool, 250 in diameter, 1 inch length, and 0.75 is the actual cutting distances here. Lastly, the diameter is 110 at the pilot. It's 150 distance there. Tip is 0.03307. It calculates that for you. 60 degree up here at the top cutting edge, and 0.750 from there. It remembers 2 flutes. Again, 250 in diameter and protruding out 1 inch. And we're going to say OK there, and that takes care of our center drill. Then we have the center drill will cover all 12 of these holes, but then we'll also cover these 3 bores as well, because we're going to use a pilot drill in there so that we can drill that all the way through and use that for machining our contour with a 1/2 inch end mill. So we're ready then now for the drill itself. So we're going to say open here, and we're going to look at tools again, and this time it's going to be drilling tools, and we're going to look for a 257 a high-speed steel drill. Now, the thread is 5/16 18. So if you look into your chart, 5/16 18 requires a letter F drill, 257. So you can grab this and hit open. And then we want to go in here and make sure that we make changes as necessary. It's going to be tool number 3. That's good. Home, home, and home. Projection is good. Looks like the collet is fine. Projection length, 2.5 inches sticking out of the collet. Cylindrical, 257. It remembers this, remembers that. And then lastly, again, tool diameter 257, 118 degree included. The tip length is 0.0772, so we have to add that to go all the way through to make sure we get a full cut all the way through, plus some extra material, of course, or an extra plunge, I should say. And then the cutting length is 2.5. Remembers that it's a 2 flute. So these values are all good. So now we have our first three tools here. Next thing we want to tap. So we're going to go in here and we're going to look for a 5/16 18 tap. It'll be under drilling tools. I want to go down here and look for 5/16 18. (5/16 18 tap. Hit open. This is going to be tool number 4. So we will make that change. On for coolant, clockwise, and so on. Again, our positions should all be home here, and this is all still good. We're going to look at the collet diameter, 1.5, 2 inches sticking out, 1.250 is good here. And then, as far as it's a cylindrical tool, again, 312 is our major diameter, 1.250. And then here, we want to make, this could probably go a little bit higher. So I'm going to say 1.5 here. I'll make it 1.75 rather. And the actual tool, the thread itself, we could make 1.5. And then we just need to go back and make sure that represents that. So 1.5, 2 inches, 1.75, it took that. And 1.5 is the amount of threads on here. And then lastly, it's 0.312 diameter and the pitch. And this is where a lot of mistakes were made in CNC 1. You don't want to force this by putting in a value that has no correct pitch or threads per inch. You have to make sure that you're putting in the correct threads per inch. If you just change this to 18, it'll come up automatically to 0.0555. There is no taper angle. The cutting length, of course, is 1.5. It remembers that. And we know that the total length is 1.75. So these values here are very important because that's going to determine how your feed rate will be affected. Your feed rate is actually the pitch times the speed in RPM, as we discussed in class. You must make sure that that is correct, and it starts right here. Feed unit, 18 threads per inch. It'll automatically put this in here, and we should be good to go. So we say OK here. So now we have our tap at tool number 4. All right, so now we are ready to do get a tool for our bore through and our counter bore. So we're going to go ahead and we're going to look for that here. We're going to say open. And we're going to be looking at not the drills this time, but the milling tools. And we're going to pick up a 0.500 finish end mill. It doesn't matter if you pick carbide, just pick 500 carbide or high-speed steel. You have a high-speed steel one down here, which will be fine. We'll go with that one. And the 1/2 inch high-speed steel is going to be tool number 5. So we're going to go in here and we're going to change this to tool number 5. And we're going to make sure that the coolant is on clockwise 100 thousandths again. We're going to make sure our positions are home, home, and home, and that this is good here. Then we want to make sure that we have this correct here, where we have our extension diameter is 2 inches. It's 2 inches protruding. The tool length here, 1.5, it should be like 1.75, so we'll make this 1.75. And then we'll go to this, it's a cylindrical tool, 1/2 inch diameter, 1.75, and then we want to make this at least 1.5, because we have to go through the 1 inch here, plus an additional 250, plus an additional 032.1 here. So you want to make sure we have plenty of flute distance to go all the way through that, and that'll certainly provide that. Lastly, it remembers the 1.5, it's a 4 flute. The shank diameter is 1/2, and again 1.7350 coming out of the collet. And we're going to say okay with that. And now there's one more that we have to come up with, and that is going to be the thread mill. So we'll go in here, we'll hit open, and again we want to make sure that we get this in the milling section, and we want to look for a 0.5 diameter by 0.0833 pitch end mill. And we're going to say okay with that. And this is going to be tool number 6. I want to make sure everything is kosher here. Middle direction clockwise, home, home, and home. Looks good here. Now if you have to change these, change them. Your files may be different than mine. Extension diameter 2 inches, or collet 2 inches here. Tool length, this could be 2.5. So it has room to get into the collet. 2 inches there. Cylindrical. Usually the shank diameter is a little bit smaller, but I'm going to go ahead and put it at 1/2 inch, so that we have a collet that's 1/2 inch. We don't have to have a size that it's not real available. 2 inch, it remembers that. 1.750 will be fine for this, for penetration. The thread mill is it's a thread mill, and there is options here of single point thread tool or thread mill with multiple edges on it. Tool diameter 1/2 inch, 60-degree thread form. 0.08333 is good. There's no taper on this. Cutting length 1.750. It's 4 flute, 1/2 inch, and 2 inch tool length. So we're going to say okay on this, and that completes our tools. Now they're out of order here. You can put them in a better order if you want. So if you right click on that, you can say sort ascending, and that'll put them in order here: 1, 2, 3, 4, 5, and 6. Sometimes that makes it easier rather than having them all scattered and mixed. And now we have all of our tools. We have them in our order that we want, which is tool 1, 2, 3, 4. That doesn't mean our milling is going to be always in this sequence, but it does mean we have the tools set up 1 through 6. All right, so we're ready now to begin our machining process. The one thing that I have to do right now is to create my stock. So in order to create my stock, I've got to create some change, a chain that will represent a 30-second on each side here that I'm going to have for my periphery. So I'm going to use line 1 down here, and I'm going to grab this right here, and I'm going to say yes, and I'm going to drag it out here and put 0.0312, hit enter, and now you can see that I have that at 32 thousandths away from the original finished part. Same thing here, hit enter, and then left click, click here, drag it out, hit enter, and then left click. Oh, didn't take that right. We'll try that again. Drag it out, left click, and we'll try that again. .0312, enter, and then left click, right click, right click, and that brings that into place. Same thing here. And now we have a 30-second on each side. So now we can go down here to keep, and we can keep this area here we want to keep. There, 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 and there. All right, so now we have the geometry representing our stock around the periphery. We'll deal with the thickness here a little bit later. Right now, we want to make sure that we have a chain that represents this extra material all the way around here. And that is for the purpose of making sure that there's stock highlighted there so you can see the machining process itself. Now we'll also have to create a chain for the real part itself too. So we're going to do two chains here. We're going to start with a chain for the stock material, and we're going to start here and come up to here. Sometimes you have to get right up to it. Okay, it's not going to take it, so I will hit escape, and this time I'll go with auto chain. And I'll pick the point, go up one, and then bring the point back, and now my chain goes all the way around. Okay. We need to create another chain that represents the actual periphery of our part. But now I want to start out here, and I want to ramp in and go around like this, come up here and ramp out. So I want basically a ramp in and ramp out here so that it starts in the middle rather than in the corners. So in order to do that, I have to create a point out here. So if I go to point down here and I hover somewhere in the middle here, you will see that there is a little sign there saying that is the center. So you click that and say snap, and it creates a point right there. Then I'm going to bring a point out in space out here. So I'm going to pick that point, left click, say copy, and then translate and copy another point out there set at -0.5. And say OK. And so it puts a point out here for me. All right. Then I'm going to create my chain based on that. So I'm going to go up here to auto chain, and I'm going to start at this point. And since I want to go clockwise because I want to climb mill around this for a good finish, I'm going to pick this line and then pick the point again. And now it creates a chain starting here, going all the way around and coming back to here. So those are very important things to do by way of preliminary setup. The next thing you want to do is to make chains for our holes. So we're going to go down here, we'll go up here to manual P-top, and we're going to start here, right here at the first hole, and progressively go clockwise all the way around. And then continue over here. All we have to look for is a little black intersection, as you see there. Then I'm going to also pick these, because this is going to be the chain for our center drill. So we're going to pick all of these, and then we're going to close it up here at cycle stop. So that gives us the chain then for doing the number 3 center drill of all these areas here. The next thing I want to do is create a P-top that will represent the 12 holes by themselves. So again, I'll go back here and start here and go around here just as I did before, but I will not do the 3 center bores because these holes are blind. They only go part way through, and I don't want a through hole for these. And then I'm going to close that. So that gives me 2 chains. Now you can check your chains over here by going into features, and you can check the chains. Make sure that everything looks good here so far. That's for your center drill. And that's going to be for just the drilling and the tapping of the 12 holes. All right, then we have another chain to create, P-top chain representing the 3 bores. What we're going to do is we're going to start out with using contour for doing these bores and counter bores. There are other ways of doing this, and we will discuss those ways, like we could use pocketing here. But for now, we're going to learn to do it with 3 pilot holes put in here before we do the contours of the bore and the counter bore, and the threading for that matter. Okay, so we got all of our chains right now that we need. There's our last one we did. So we should be good at this point for being able to do the face milling operation and everything else with including the drilling and the tapping. All right, so I got my chains, so I'm ready to go. I'm in machine, okay, which is what I want to be. And the first thing I want to do is highlight the chain that's going to represent the face milling operation. So I'm going to grab this right here, which is our extra material. We want to make sure we grab the extra material, because if you had a 1/4 of an inch on each side, your face mill is going to have to step over more times. In this case, it's so close to being the size of the material, we could have used either one of these chains. but just because of doing it the correct way, we want to grab the chain that represents our material. And then we're going to say machining, solid mill traditional, and we're going to say facing. And we're going to go in here and we're going to make sure we have face mill activated here. 2000 is good RPMs, 20 inches a minute, and the plunge is going to be 18. Strategy is going to be zigzag. There are, conventional climb or zigzag. Zigzag is very good for this. 1 pass, no. Cutting angle, optional cutting angle, we want to say no there for that. And we're going to go angle 0. Actually, we should probably leave this. Let's just try this at yes first before we do that. Step over, 1 inch, 50%. Overhang, 1 inch, 50%. That's all good. Bridge percent of feed rate is 100. Overhang direction, one way. Include islands, no. No stock allowance on the walls of the floors. Remember, we're going to face off a 32nd off of this, and that is going to give us a Z0 face when we're finished. So we don't want to put anything in here under total depth. So you leave them blank. There is no stock on the floors or anything. If we had a 1/4 of an inch or more for this, we could put a stock allowance on the floors of, let's say, 1/8 of an inch, and then take 1/8 of an inch off twice to bring it into size. But today, we only have a 32nd on here. We can do that in one cut. The links on this, full clearance 1, clearance is 100 thousandths. The return plane and the retract plane will be set to clearance. Down and over is the way we go down here, and we move into G41, G42. When we're done, we will over and up. So we'll come over here and come straight up to Z0. All right, and we're going to say OK, and take a look at how this looks here. So it's got these loops, which is what you want. And I'm going to put this in isometric here. Whoops, up here, isometric. And then I'm going to go to my parameters, my simulation parameters. I'm going to change this to plot geometry. I'm going to slow this down. I'm going to go into solids. I'm going to use extrusion. I'm going to allow for 0.0312 added to the top of our piece, right, for something to face off. And then the Z minus is going to be 1.250, because that's the thickness that it will be before we do the machining operations on it after and complete it. I'm going to say transparent here for this one. You don't have to, but I'm going to use transparent. I'm going to say add here, and I have to pick the feature that I want to pick. So I want to make sure I pick this feature right here, and say okay, add, and OK. So now if we go ahead and do this and try to simulate this, we will see that it faces it. Now I need to go up here and make sure that view shaded wire is on so that we can see the operations better. So now you can see it taking off the material, and you can see the geometry, so you know you've taken off a 32nd. If you're still not sure, you can put this in front view and take a close look by watching it go across there in single stroke. You can see the 32nd right here, and if I do this in single step, and if you look carefully here, you'll notice that the tool comes right down to the surface here of this line, which is our finish line, okay? So that looks good. Go back up to isometric. And now we're ready for our second operation, which is going to be milling the periphery. Now this time I'm going to have to grab this inside chain that I created, because that has the start point out here and in here. And I'm going to say machining, solid mill, traditional, and I'm going to say contouring. All right, first thing it's going to ask me is what tool are we going to use. We'll use our 1/2" end mill. We're going to make this at 1200. We're going to make our feed rate at 20 and our plunge at 18. The strategy is going to be climb milling. Width is good here. Spiral move, no. Stock allowance on the walls, yes. 0.01, but nothing on the floors because this is a through piece. So we want to machine only down to where it needs to just get down past 1 inch and then stop. So our depth then, this will be 1.250 to make sure it goes up. Not 1.250, 1.050, yeah, 1.050. So 1 inch 50 thousandths, we might want to go 25 just to make sure we don't go down too deep here. We only need to machine down here 1 inch 25 thousandths to get past the thickness of 1 inch here. The rest is going to be in the vise. We want an incremental depth of 250 here. There's no starting depth. Retract is none. Read taper from the feature. We don't have to have any reading of the taper. There is no taper here. This is going to be cutter comp left and cutter comp left. We want to say yes on offset the tool radius because we want to do center point programming, which means that we're machining everything from the center point, so this would be 0 rather than half the cutter diameter. No stock automation at all ever, because that creates a lot of problems. Advanced, tricoidal move no, trimming collapse, these are default and they're perfect. Tool blend no, and that's if you want to go around the corners and blend it. We can talk about that another time. and the blend radius you can put in here if you want. At that time we'll talk about it. And then the links, where it's 1 inch full clearance, 100 thousandths clearance value. Full clearance is what we retract between the cuts. And then if we can actually put in here, the retract can be just clearance between the cuts. Surface clearance would be good. That'll be 100 thousandths. Entry mode down and over, which is good. Feed over, wrap it up is perfect. Position radius. Now, we can allow for a position radius here, and we can put in here a value of, let's say, 0.100. And it will give me 100 thousandths now of radius once I come in here and approach this. So the approach then is here and here. And then I can hit OK. And you can see that I have this little teardrop that goes in there and cuts and goes around. So now we can go ahead and we can check this out and check out the entire operation. You can go to your operations page. You see that you have facing and the contour. Now, this needs to change here. You're not doing the 922 contour. So if you double click on this, you can go in here under General and you can put in here Machine Periphery. Okay, and that'll suit for that one. Then on the first one, it is already facing, so we're basically telling it exactly what the operation is going to be, and that helps in the future when you are looking at a whole bunch of things here. You can tell which operation is which. Sometimes it's good even to put, some other indication here of what tool you're using. If you wish, you can do that. It can say machine periphery with 1/2 inch tool, but we already see that here. So let's go ahead and machine this and see how this looks. So now we have a 200,000 step approximately here for sitting in the vise. We can also look at the top view here and see if we still have some material on here. I'm going to rotate this just a little bit here, and I'm looking at this value here of 10 thousandths to take off yet. So we know we did the rough cut. All right, so we can again go to our 3D view and we can make a final machine cut. So you can go in here and see, go in here and double or change this machine periphery rough, and that'll help us to understand what is being done. Say OK, and it's going to remember that. Now Esprit is very good at remembering the total operation, so it'll remember this. I don't really have to copy and paste. I just need to grab the same chain for that periphery, which is this one here. So I grab that same chain, machining, solid mill traditional, and contouring. And this time we're going to just change that. Everything is the same as what we had in the previous, but I'm going to say finish here. All right, it's still the 1/2 inch end mill. The speeds and feeds will be the same. The strategy will be the same, climb milling, but there will be no allowance on the walls now. So it'll be 0 here. The depth will still be 1.025. It's going to be cutter comp left. And something that we need to look at is make sure that the offset register is correct here. That's something I should have actually told you to do before. It is the 1/2 inch end mill. It's tool number 5, so we're good. We can come back to the operation now and know that that's fine. Usually Esprit does not put in here the right number, so you have to come in here and double check this to make sure that the offset number is the same as the tool number. And go to advanced, everything is the same here. Links are all the same, nothing is going to change, and your start point and end point is the same. So I can say OK here, and this should now do the final finish cut. So if we go ahead and simulate this whole operation. Now I do see that we're doing our finishing operation in steps, and we don't want that. So let's go back and look at the periphery machining operation after we shut this off and take a look at why that is the case. So strategy says that we are going to do incremental depths for the final cut. We don't want that. We just want to make this 0, and we want the total depth to be 1.025. And then the advanced, we'll double check here to make sure everything is good here. Links, down and over, and wrap it up. That's all good. This is all good. So that should change that and make that correct. So now if we do the operations again, that should fix that. And there's our final finish right there. Now we can double check to see if we truly machined off everything to that chain. And there's our chain. If we rotate this just a little bit, you'll see that we have machined right to the surface that is a finished surface, okay? So I'm going to go and bring this up to isometric again. If you want to, you can go in, if you don't like the translucent appearance here, you can go in here and say, uncheck the transparent, hit update, make sure you say update, and then say okay, and then when you do the operation now, you will see a solid, okay? So that's up to you how you would want to do that. Transparent is good when you're trying to look at how deep your holes are. So that's why I use transparent a lot. So that all looks good. I'm going to go ahead now and say File, Save As, and I'm going to be going back to my files to get back to your files here, okay? And this time it's going to show Lab 1, and I can go down here and say All Files, so you'll see them all. But you're going to see Lab 1, drill tap bore plate, and it's going to be an ESP file. So if I hit Save, and I hit Open again, you will see that it is now an ESP file, a Esprit document. So when you come in here again to do the next operation or next session, this is session 1. The second session, you'll have another ESP file for that one. Or we'll just not really, you'll just have the same one. We'll just be adding more operations to it. Sorry about that. Okay, so that's basically it. We can basically stop right here, and we'll go to the next session, session 2, in the near future. So I'll talk to you then, and have a good day.